So today what we're going to talk about is compounds, mixtures, and electrons, orbitals, and outer shells. So here we go. So the first thing that I'm going to do is I'm going to go ahead. It's too loud in here. The first thing I'm going to do is title it. So my first one's going to be compounds. I'm going to date it, today's date, and the number. So today is our 77th thing for the year. Okay, compounds, we want to define them. Most of you know what compounds are. So let's see how you do. Remembering from your past, what is a compound? Yes? Two elements combined. That's kind of it. There's a key word we're missing. Yeah?
To create something new? Is that it?
They do create something new once they combine. They fuse. What's that word?
Fusion.
No, that's a nice idea though. They chemically combine. Okay? It's not really fusion. So let's tighten that up a bit so we have a good working definition.
Two elements chemically combined. Combination.
I'm going to write it this way. Combination of two or more. And you can say atoms or elements. We use them interchangeably. Chemically combined. So the key word there, really, you're looking at is chemically. The other definition we need, now that we have compound, it makes it a little bit easier, is we have mixtures. So once you've written down what a compound is, the combination of two or more atoms or elements chemically combined, what is a mixture? Go ahead.
Isn't it two or more atoms down?
Right, they're not chemically combined, and then there's another word I like. So I'm going to write the definition like this. I'm going to say the combination of elements that can be physically separated. So they're close to each other, but you can just kind of move them apart. Combination of elements that can be physically separated. So basically the difference between the compound and the mixture is compounds are chemically combined, C and C, that's nice. And the mixtures are not chemically combined, so you can physically just separate them out. Question?
So like chemical combined means you can't like
Right.
it's like fluid.
Sometimes we have things dissolved in others, but we could physically separate them back out.
Oh, like salt. Oh.
Yeah, like salt water. Okay. So what I'm going to do is I'm going to go ahead and put some things on the table, a bunch of atoms. Okay, so I have all these atoms. They're different kinds. And they're just here on this table. Now, do I have a compound? Or do I have a mixture?
Mixture.
It's basic because I can separate. Ooh, I can do yellow, separate them into yellow, separate them into greens. I can separate them into lids and pens. I can do all sorts of things, physically moving them around, right? I could do that. Now, what happens is if they're chemically bound to each other, you can't just go in and easily move them apart. So let's say I want to show compounds. So I'm going to go ahead, I've got black molecule or a black atom and a yellow atom together now. They're chemically bound. That now is a compound. I can't easily just separate them. They're bound together. They totally became something new. Instead of something all black, it's now yellow black. Okay? So I'm going to go ahead and make all these compounds. I'm going to make that compound. So because I can't just easily separate them, they're chemically combining. These are now compounds. Okay? Except the red one, you've got me. Let's move that. Yeah. Okay, there we go. Now, you can have a mixture of compounds, which is what this is technically, right? A mixture of compounds. Because some of these compounds I can separate back out. So let's take all of these and make one compound. What would we do? Chemically combine them all together, right? So we could do that. So these are chemically now combining together. So the question is, here you have this. So do you have all lids? No. Do you have all just the marker portion? No. You have lid markers. It's totally something different. So, and they're chemically combined. So this would be the compound. So it's that idea, okay? So that's a difference between compounds and mixtures. So what we're going to do now is put down what are the things that compounds have in common. There's 6 things, and you need to know these 6 things for your quiz. Oh, I'll make that bigger. The first thing is that compounds have fixed ratios. Of atoms. I'm going to talk a lot today about water because you guys are familiar with water, you've interacted with water, you know what it's about. So if we're talking about water here, it looks like H2O, you guys know that. Water always has 2 hydrogens and an oxygen. That's that fixed ratio. So the fixed ratio is 2 to 1. Okay? Now if it's 2 to 2 or 1 to 1, you don't have water. It's got to be 2 to 1. So if we had 6 hydrogens out here, just out and about, 1, 2, 3, 4, 5, 6. 6 hydrogens. In order to get water, how many oxygens are we going to need? 3. 6 divided by 3 is 2. 3 divided by 3 is 1. So you still have that magic 2 to 1 ratio. So we'll add 3 oxygens here. So we'll take out these 2 hydrogens, set them aside. Take out these 2 hydrogens, set them aside. And the last 2 hydrogens, set them aside. Take that oxygen, put it here. Oh, I did that wrong. Sorry. I got ahead of myself. That last set of hydrogens right here. So we took away 1 oxygen, put it with this one. We're going to put this oxygen over here and this last oxygen over here. You can see that we have water and that they're all the same ratios, 2 to 1, 2 to 1, 2 to 1. Okay? So that's what it means when it says there's a fixed number or a fixed ratio. Most matter on Earth is in compound form. So most matter on Earth is a compound. Matter contains specific combinations of elements. Or atoms. So again, with water, you have your oxygen, and then you have your hydrogens. So now we kind of know where the H's are in compared with the oxygen. And all the waters are going to look the same. All compounds have the same properties. So all water compounds have the same properties. So they freeze at the same temperature. They're going to boil at the same temperature. They're going to have the same properties. The density will be the same. Okay? So it doesn't matter if I have a cup of water here in Idaho, or if I have a cup of water in Florida, or a cup of water in Egypt. All the water is the same. It's H2O, and it's arranged the same way. It's all going to freeze at sea level. Okay, altitude's a variable. But when the variables are the same, they're all going to freeze at the same temperature, boil at the same temperature, have the same density. Okay. All right, next one. They're going to act in predictable ways. So I like to swim a lot. So I will swim in freshwater lakes. If I jump in a freshwater lake, I kind of know how my body's going to feel, how it's going to enter the water, and what I need to do to make sure I don't hit the bottom or, jab my leg or something, whatever I want to do. I can swim. I can practice on my swim strokes if I want, and I can do that in a freshwater lake again here, and I can do that in a freshwater lake in Colombia, and it's going to be the same. Okay, this water, these compounds act in predictable ways. There's no mysteries. Okay, they're chemically, we know that, chemically combined atoms or elements. Okay. 1, 2, 3, 4, 5, 6. So those are the 6 things that compounds have in common. Make sure you know those. You can list those out on your own without being prompted. The next thing I'm going to do is see if you can fill in the blanks. See how you do. Any ideas? Blank combine to form blank. Once that happens, those then combine to form blanks. Any ideas? Yeah?
Mixtures combine to form compounds, and compounds combine to form mixtures.
Kind of. We're good. This one, number 2, we'll put in one of the words you said. We'll slowly fill these in and see if you think the other ones can reveal themselves. What combine to form compounds? Okay. It could be elements or atoms. We're going to go with elements because we know that atoms want 2 or more atoms is an element. So we're going to say elements. It could be atoms. You're right.
And atoms combined.
And then there we go. Atoms combine to form elements. So make sure if you see these blanks, I would probably give you one of them to jumpstart and refresh you, that you could fill in the rest. So you know that atoms, if this one was blank, combine to form elements, you know that atoms would go here. And then if you were given atoms, you would know that elements goes here. So make sure you know those blanks and can fill those in. Okay, now question. If I took and shook salt and pepper together and put it on the table, is that a compound or a mixture? Mixture, because I could separate those out. I don't want to, but I could physically separate them. Now, what if I had a nice warm thing of salt water? What is that? It's a mixture because even though it's dissolved, I could let or boil off the water and the salt would be left behind. So I could physically separate it that way by allowing a natural process to occur. So it's not a chemical compound. Okay, last page. Here we go. Where are electrons located? Outside the nucleus. Yeah. Okay, so let's write that down. Electrons are found outside the nucleus. And you're going to hear lots of terms, so I want you to be familiar with all of these. You're going to find them outside the nucleus in shells, clouds, orbitals. So you can use these interchangeably. If you see one, know that it could be called something else. So be familiar with that. They're kind of like synonyms here. So shells, clouds, or orbitals. So we're going to draw one. We're going to use carbon today. So carbon, the atomic symbol, it represents the nucleus. So we're going to then go ahead and put the shells. Carbon has 2 shells, clouds or orbitals, around its nucleus. So what we want to do is look at carbon on the periodic table. How many electrons are in carbon? 6. Okay. So on the periodic table, the atomic number is the same as the number of protons, is the same as the number of electrons. So we know that in the stable form, carbon has 6 electrons. So we're going to put those in this shell. Shells. In the first shell is small that it only can take on 2 electrons. So in the first inner shell, we're going to put in 1, 2 electrons. But we have a total of 6. So we need to put in the remaining 4, because the next level out can take 4. 1, 2, 3, 4 electrons. Now carbon only has 6 electrons, so we want to count and make sure that's right. 1, 2, 3, 4, 5, 6. Good. So we have carbon, we have 2 shells, 2 clouds, 2 orbitals, and 6 electrons. So we're good. Now this outer, you have an inner and an outer. This outer ring is called the outer shell. So you'll probably see a diagram like this on your quiz, and you'll need to be able to label it or name it or draw it when asked. The electrons in the outer shell of whatever element you have, the one in the outermost circle, are called your valence electrons. Those are only the electrons in the outer shell. So I'm going to highlight those. So my valence electrons are here, 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 and here. There's 4 valence electrons. So carbon has 6 electrons. And 4 valence electrons. There you go. Now when we draw these electrons to figure out how they're going to chemically combine with other things, we only draw the outer shell electrons. So we're going to draw carbon. We're going to draw the 1, 2, 3, 4 valence electrons. And then I'm going to show you hydrogen, which only has 1 valence electron, only 1 electron. So that's its valence electron. Okay, so all atoms want a full outer shell. A full outer shell is how many? 8. 8 valence electrons. And that is called the octet. Oct for 8. If you've heard that before, the octet rule. Exception. Hydrogen and helium are happy, are full with 2 valence electrons. Okay. So we're going to go ahead and show what happens here. So we have carbon. We draw its valence electrons. It's not happy. It needs 8. It only has 4. We're going to take hydrogen with its 1 valence electrons. It's not happy. It wants 2. Okay? So what will happen is these will chemically combine and they'll form covalent bonds. So we'll have the hydrogen will come over here and it will share its electron with carbon. So now the hydrogen's happy. This hydrogen's happy. Carbon still no. 1, 2, 3, 4, 5. Nope. Another hydrogen will come along and share its electron. This hydrogen's happy. Not carbon. Another hydrogen comes along. It'll share its electron. Happy? Not quite. We've only got 7. One more hydrogen comes along, and now carbon is good. 1, 2, 3, 4, 5, 6, 7, 8. Every hydrogen has 2. Happy. Okay? So when there's the sharing of electrons, a covalent bond is formed. So carbon has 8 valence electrons, and all the hydrogens have 2 valence electrons. Okay? Questions on that? So you want to know what the valence electrons are called, and you're going to want to know where they're located, and that they're, what's the outer shell or not the outer shell. And where electrons are found, which is a little bit of a review. We've already answered that. Questions? Okay. So let's go over your quiz. I would go ahead and look at your periodic table. And there's a note you can use on your periodic table to help you with today's practice problems. And it will be, how do you find the atomic mass? So it's number of protons plus number of neutrons equals atomic mass. So here you go. Go ahead and write that formula down as well, so you have that on your periodic table. The 3 notes that I've written for you and you've written on your periodic table will be available to you with a periodic table for your quiz. I will come around today and stamp your comp books. So you need to make sure you have those today. So let's go over the stuff for the quiz. You've got your periodic table. You want to make sure that you know where the subatomic particles are located and what their charges are. How to determine the numbers of each one by using the periodic table. You want to make sure that you can determine what an ion is. You need to know that ions is when the number of electrons changes. So when you see a problem and you're given different electrons and different neutrons from the periodic table and you're asked to find an ion, you use electrons, not neutrons. If you're asked to use an isotope, you're using the information about neutrons, not electrons. So make sure you know that isotopes are difference in the number of neutrons compared to the periodic table. This is probably the one thing that kids have struggled with the most, is determining whether you have a neutron or not. What do you have? Compare it to the periodic table. If the numbers of neutrons is different, you have an isotope. If it's the same, you don't have an isotope. Make sure you know what a coefficient and subscript is and use those to determine how many of each atom you have, how many different types of atoms are there, and what is the total atomic mass. Okay? We did a lot of practice on that. You turned that in today. We should be able to get these back to you today. So if you got some wrong, you can fix it. Compounds, make sure you know what a compound is. What are the 6 things all compounds have in common? Be able to list those out, freestyle. Be able to fill in these blanks. Make sure you know where electrons are found, what those names are. Where are the valence electrons? What is that outer ring called, that outer shell? And then be able to do problems like your classwork today. So here's your classwork. I'm going to pass, well, let me just explain something real quick and then I'll pass this out. We'll practice a few problems. So you want to make sure you go with what you know. What never, ever, ever changes. Okay, there we go. You know that. So you can go, this says carbon. This is the number 6. It's hard to read. And this says cesium, C-E-S-I-U-M. Okay, so what happens is kids will get to this part and there's a couple things. They think you can't have the same element twice because it's like a rule in worksheets or something that you can't use the same word or have the same element twice. Get rid of that. You know it, you know it. So make sure the number of protons, do those first. Number of protons always equals the atomic number. So if you know one column, you know the other. That's easy. Right away you should do those. Okay? Then what I do when I'm finding that things are difficult or there's kind of a formula, I write it on my worksheet. So I know that the number of protons plus the number of neutrons equals the mass number. Okay? So here I've got the atomic number is 8. That's easy. Protons 8 because they always match. And then I've got 8 plus 8 equals what?
16.
Boom. So go with what you know. Fill out your protons. Fill out your atomic number. Work the math. Now if you're missing one, I've got 6 plus what equals 14? Boom. That's it. It's pretty easy. You're going to have 5 minutes working on your own. Then no table talk to neighbors. See if you can figure this out. And then we'll open it up to table talk if you need it. Okay? And this is number 78.
And is it due at the end of
Yeah, it's due today. You'll be done.
Okay.
Yeah, we've got 42 minutes. We should have time to spare. Okay?